Alright, in this video I'm going to show several things from a new model to exporting a mesh, and then I'm going to show it finally running on the iPhone and it's fully animated and blinking. So the first thing I'm going to show is the new mesh that I got from the 3D modeler. So it's selected in object mode. So he's like a skull conquistador or skull pirate. He comes in at around 2,000 triangles, which you can see over here, which is within the polygon budget that I outlined. So that should render fairly easily on the iPhone. And he's got his conquistador helmet. Also sort of like a skeleton kind of character. If I do the wireframe, you can see he's got a big helmet. So that's the latest mesh that's come in. And I'm just showing this. This is how I get the meshes. So then the mesh is final. And the next step will be to texture the character. But I get the finalized mesh so I can look it over here. And if there's any issues, I can point them out. But there's no issues with this mesh. It's perfect. Looks great. So now I'll move on to the character we're going to export that's been skinned. So here he is. I'll select the so that's his skeleton. This is what gets animated, and then since the vertices of the triangles are bound to certain joints in the skeleton, then they're deformed as the skeleton animates. So you can see it's a fairly basic skeleton, which is what you need for the iPhone. You can't really do a very complicated skeleton because, again, I'm doing this on the CPU, and as always, mobile phone CPUs are fairly constrained. So for instance, there's no rigging or no joints for the fingers or the hands because I don't really need it for this game. So the simpler your skeleton rig is, the quicker it'll be able to be processed on the iPhone. And if I show the animation, yeah, here you can see it's just a simple breathing animation. It's just a test animation so that I can test this running on the iPhone. And if there's any issues, it's fairly easy for me to detect what went wrong since the animation isn't complicated. So there you can see the animation animating. So as you can see, as I said, the skeleton moves, and then the meshes that are bound to certain joints in the skeleton are deformed as a result. Of course, each vertex has a weighted average to the skeleton joint, and that determines the contribution of that joint to the vertex position when it gets animated. So a simple animation, which is exactly what I need so I can test this on the iPhone. And later I'll be showing the this same animation on the iPhone, which I export as always using my exporter. I can set certain options, for instance, animation, frame rate, starting frame, end frame. If it's 0, that means just export the frames that are in the scene, and I can duplicate the first frame as the last frame if that's what I need. So there you can see the mesh. Someone asked me about the eyes, like how I do that. I guess from another video where I mentioned eye blinking. And essentially it's just a separate mesh. Like I can select it here. Get it close. Yeah. So the first one is the upper eyebrow, the green one, and the white one is the eyes. So it's just a separate mesh that I export. But I do a special export if I, yeah, mesh. What I set this option to transform by inverse bind pose. And what that's going to do is it's going to take this eye mesh and it's going to find out the joint that it's that the mesh is skinned to, which is the head joint. You can see that. I'll select it right here. It's bound to that head joint. So what it's going to do is it's going to transform the eye joint into the or it's going to transform the eye mesh into this head joint's local joint space. So when I export, the eyes will not be in this position. Let me move out. So what'll happen is these eyes will be somewhere down here because that's where the joint's local position is. So it'll be in joint space. And I do that so that when I'm rendering this in on the iPhone in the shader, what I will calculate in the engine is the global world space of this head joint. And since this isn't, the eyes are saved in the local joint space, all I do is I set that world space position for the joint as the world matrix for the eyes, and then magically the eyes will appear in the exact location that they're supposed to be, like is shown in this model. And I also do that so I don't skin eyes or anything that's a rigid mesh on the CPU, for example, because there's no need. Since this is just rigidly bound to one joint, it's just better to have that processing be done on the GPU, because eventually I could attach more things on this model. For example, I could add a backpack, some swords, you know, or axes or whatnot, and I just don't want to be skinning that on the CPU when I can just as easily have it done on the CPU, or on the GPU, sorry. So the same with the backpacks. I would just transform the backpack into the whatever joint, it's local space that it's attached to, and then I just set the world matrix for the backpack to the world space joint that it was attached to. So that's pretty easy to do. It's not that hard. So the next video, or not the next video, I'll attach it to this video. I'll show the character running his idle animation, and then we can see the eye blinking. So I'll show that in the next video. In this video, you can see the character finally rendering on the iPhone, and it's the same animation that I showed in Maya. And also you'll see the eyes periodically blinking. I think he just did one. Yeah, there you go. So I can troll him around. Again, you can see the back. So it's the same animation, everything exported correctly. And again, you can see the shadow map animating with the animation. So the way I do the eye blinking is I save, there's an open mesh, which is that one right there, and then there's a closed mesh that you see. And I just switch between them periodically. It has a random amount of time that it stays open, and then it just shuts. And that's pretty much all there is to it. And as you can see, the attachments are also working properly. So the eye was originally saved in the joint local space, and then I just set the world space for that joint as the world matrix for the eye, and then it gets positioned correctly. And I'll use the same technique for swords, backpacks, or anything else I need to attach. Of course, the limitation is the eye can only be attached to one joint, and it has to be rigidly bound, so the weighting influence of that joint is 1. It won't work if you, say, attach the eyes to 2 different joints, or if the vertices are attached to 2 different joints. Everything has to be one joint, which is okay. That's a reasonable limitation because, again, these are rigid meshes that you're just attaching to a skinned mesh base frame. So that's not a problem. But as you can see, it's all working well. Let him blink a little bit more. Sometimes he'll blink more than once, like twice repeatedly. That's a behavior I coded into the system. And I use I guess we could call it a design pattern. It's called the entity component system. So the entity, which is this character, really has there's no code for the entity. Everything's in components. So the eye blinking, there's an eye blinking component which has all the data necessary to blink the eye. And then there's an eye blinking system which takes that data and executes the code on it. So every system is completely independent of any other system. And the good thing about that is you can look at a system and be perfectly confident that it won't mess around with any other system, so there's no weird, complicated interactions. And a system, since it's independent, it's fairly easy to thread any particular system in the engine, so that's an added side benefit. So that's what I have to show for this video, and probably the next videos I'll show different characters running this same breathing animation so that you can see that I can have different meshes bound to the same skeleton and they can all share the same animation sets. And the advantage of that, of course, is savings on memory and cost. So till next time, that's it. Thanks and bye.